We're going to use motor encoder counts to help robots drive a specific distance. To do that, we're going to need to find the circumference of the robot's wheels first. To work with numbers in RobotC, we need to recognize there are different kinds of numbers. The first is int, which stands for integers. The second is float, which we use for numbers that have decimals or fractional parts. To find circumference, we need to find the diameter of the wheel. And that diameter may not be a whole number. As you can see here, my wheel is about 2 1/8, which is 2 125 thousandths. So I need to make sure I call that a float. And then I'm going to put a little comment after it saying it's in inches so I don't forget. The circumference might also not be an integer, so we need to call that a float. And that circumference is going to be equal to the diameter of the wheel times, which is an asterisk, pi. In pi you could put 3.14, or you could actually type the capital letters pi for pi. So we know the distance around that wheel. We need to know how many times that wheel distance goes into the total distance that we want to go. And if I know that my distance is a whole number, I could use int for integer, or I could use float if it isn't. My rotations, that's the number of turns of the wheel that goes into the total distance, is found by dividing the distance to go divided by the circumference. And I made a mistake. That shouldn't be an int. That should be a float. We don't know that it'll be exactly a whole number. To find the total number of degrees the wheels need to turn, we multiply the rotations by 360. And you could use a float, but I'm going to use an integer since degrees are so small we could round it to a whole number. Now we know how many degrees the motors need to turn. We can use the motor encoder variables to make our robot move that specific distance. Remember, if you double click on them and go to the help menu, they have very nice examples. They explain how to use them. Motor encoders for finding what degree it's at. Motor encoder target is for setting it what degree you want to get to, or what encoder count you want to get to. And when the motor gets to that encoder count or degree, the system will put the motor back into idle or stopped state, so it won't go over. Here they have an example for setting the target on one motor. They also have a second example for setting the target for two motors. Let's start by setting the target for one motor and see how that looks. First step is to set the motor that you're checking to 0. So get motor encoder. We want to set that motor encoder to 0 so that we know where we're starting. Next, we need to tell what target number of encoder counts or degrees that we want to get to. And that's going to be equal to the degrees that we figured out earlier. Next, we turn the motors on since we're finished setting them up, just like normal. Next comes our loop. We need a loop to keep checking over and over for when that motor reaches its target. So we're going to check motor B to see when it's finished. We're going to need a while loop since we don't know how many times we need to check. Inside the loop, we're not doing anything because the real work is the test. We want to find out when it's finished. So we're just really just waiting and checking over and over. We want to check the run state motor. We're waiting for motor B to not be equal to run state idle. So we're going to stay waiting if it's running, and as soon as it's idling, we're going to leave the loop and go on to the next step. The exclamation point equal means does not equal run state idle. Finally, all we need to do is tell the two motors to turn off because we've reached the target encoder counts, the number of degrees that we wanted, so we can turn off both motors. Alright, let's compile it. We see we got an error. The X is on the left hand of the code, indicates where the errors might be. We can also check the error panel down below. We can see that it says it's expecting a semicolon. Found a float instead, so that means we're missing a semicolon. If you look at my first line of code, I'm missing a semicolon after diameter of a wheel equals 2 1/8 inches. Okay, maybe that fixes our problem, so let's check it out. Let's compile. It says I still have some errors, but it did fix those first ones. So let's go down and find the next one. In the panel it says degrees to turn is written. So when I found the number of degrees, I called it degrees to turn. But later on, I called it degrees when I used it. And that's not right. You have to use the same name for the variable. Otherwise, the compiler doesn't know what you really mean. Alright, so my ruler's out. I have it move a foot. But you can see that one of the motors is off. And I'm guessing that it was motor C because we weren't actually checking that one. We were only checking motor B. So let's set the target, the encoders to 0 for C, and also set the target for C so that we check both motors. Okay, so now both motors, we've set a target for the number of degrees to turn. And now we need to also go into the while loop and check both of them. So after run state idle, that check for motor B, put 2 ampersands together. That means and. And then we're going to copy that same code and use it to check for the run state of motor C. That should be the only additions we need. Now let's test it out. My robot starts at a foot and drives to the beginning of the tape measure.